Howdy, AP PreCal. It is Ms. Kosh. We're continuing. This is the second part of my notes for 2025 for section 3.1, periodic phenomenon. So you can go find the first video, and here we continue. So this one, I did use a little piece. This is actually a trig function that we'll study as we keep going. But I was trying to, if Desmos had a way for me to put like little arrows here, I would do that. There they are, but I was too lazy to type it up. So I told you that the range is from negative infinity to positive infinity. So what's happening is we have these little asymptotes. Okay, so looking at this, they've given us a portion of this periodic function. I see this little pattern right here, and if I pick this up, I can shift this, and it's matching all these other, and so there would be one here. If I did that correctly, there would be one here, okay? So we have all of these little guys, and so there's a piece of the periodic function. So what we might want to do, okay, first question, what is the period? Well, how long did it take it to do everything it's going to do? Well, it kind of lived between these two asymptotes. So everything it did, and you could kind of compare, okay, so or we could think, well, from this 0 to this 0, I was at 5, I got to 7, so that's a difference of 2, so the period, or you can go from 0 to 2 over here, the period is 2, no matter how you look at it. I deleted too much. There we go, the period is 2. Okay, so it might be helpful to do what we did in the previous video and say something like, well, if I have f of 2k, well, let's first say this. Let k be not just any variable, but let k be in particular an integer. If I'm looking at f of 2k, what I'm finding here, plug in 0, I'm at 0. Plug in 2, I'm at 2. I lied. Plug in 1, I'm at 2. Plug in 2, I'm at 4. And so these are all asymptotes, and my function is undefined. Okay, and then what do I see? Well, then I see an f of, I don't really like decimals, 1/2 plus 2k. That would be these scenarios here, so 1/2, and then 2.5, and 4.5, and 6.5. These are now all equal to, they have an output value of 1. F of, what's the other one? 1.5, okay, 1.5, 3 halves, I don't know, whatever. I should have just stayed with decimals because that's what I did this whole time, but, whatever. So plus 2k. These are appearing to be equal to -1. And those are the three main situations. Oh, no, there's a 0. I should have done in the middle, but it doesn't really matter. Of 1 plus 2k, this was equal to 0. So that's giving me 1. And then this is a nice little expression for all odd integers. So my IB kids see that with some frequency. Well, they would see it this way, 2k plus 1. Okay, so now let's look at the particular scenarios that they asked us about. I don't need that anymore. And so they said g of -8. Well, g of, this is 2 times -4, and that's just this first scenario, and so this is undefined. That there will be an asymptote at -8. G of -2.5, okay, so let's see. We could do g of, what do I want to do? -1/2, I don't want to use a -1/2, I'm going to say a +1/2 plus 2 times, no, that's not what I want. But here we go. If I'm 2 times -2 is -4, and then I need to go 1.5 from there. So that's 3 halves. Do we agree with that? -4 minus 1 is 3 minus 1/2. Y'all, I'm still technically on Christmas vacation. So my math skills are lacking, or rusty. Let's go with that. Okay, so that's equal to -1. G of 11, well, that's just one of these odd numbers, so that's going to equal 0. So maybe we recognize that pattern. If not, it was this scenario, so that equals 0. 13.5, I can say, okay, this is, well, do I want to do 1/2 plus, nope, because it's 3 halves away from an even number. So 3 halves plus 2 times, in particular, we would have plugged in a 6, right? 12 plus 1.5 is 13.5. Okay, and so this 3 halves was the -1 scenario. -19, why did I write this? Okay, we're fine. It's fine. We're great. Okay, so this is going to be 1/2 more than 2 times -10 is -20. Yes, so -20 plus 1/2 is -19.5. Okay, so then what happened when I had the 1/2 scenario? That was equal to 1. Okay, Then I say a portion of a periodic function is shown below. Write expressions that find each of the following. Okay, you may notice, well, let's first of all figure out the period. So what is happening? It kind of curves down, and then it comes straight, and then it curves around here, and then I see a straight line. And if you notice, okay, I think I did it in multiple pieces. This whole thing can shift, but I think I forgot to do the last little piece. Okay, which is why I had to change my directions. I had initially said 2 periods of the function are shown, and then I was like, oh, no, they're not. But anyway, change directions, and everything, the math is still valid. Okay, so looking at this, how long did it take it to do everything it's going to do? What is its period? It did everything it's going to do by 9. And so the period here is 9. And so now it says, okay, where does it have a local maximum? Where h is a local maximum. I see a local max here. I see a local max here. Yeah. So they're 9 apart, and it's just, okay, when x is equal to 9k, but maybe we should say the k has to be an integer. Okay, so a local minimum. I see a local minimum here at 6. And then the next one will happen 9 units later, and then there will be another one 9 units after that, and etc. And so we have x is equal to 6 plus 9k. Okay. X is increasing at an increasing rate. Okay, so what does that mean? At H, I just said X, I meant H. H is increasing at an increasing rate, so that means that the graph is increasing and it's concave up. Okay, so the graph is increasing here and it's increasing here, but there's no concavity on that second part. If I drew it correctly, you could see that a little better. But so we're going from 6 to 8, but in that interval, 6 to 8, we also have to repeat this every period. And so it's plus 9k on both of those. So I don't think AP PreCal will ask you to write an interval in that notation, but I do think they would say what's happening to the graph on the interval from 98 to 100. Well, so then you'd have to figure out where does that fall and what you have. They'll ask those sorts of questions. Okay, so just I'm trying to give you different ways to practice some of the same ideas. Okay, H is increasing at a constant rate. So this is just all kind of a mess. Let me kind of clean up some of this. I almost cleaned it. There we go. Okay, H is increasing. I need a graph that's increasing at a constant rate. That means I need it to be linear. And so the linear piece here, it goes from 8 to 9. And so we can go ahead and say 8 plus 9k to 9 plus 9k. And we probably should say that so that when you plug in, you'll plug in the same k value for both of those. So like I can express 9 plus 9k as just 9k, but then that means I have to plug in different k values here and here for it to be valid. So does that make sense what I'm trying to say? If I have 9k, then I can plug in different k values. I can plug in 0, 1, 2, 3, and this is 0 and 9 and 18 and 27. But then if I tried to say k and then 8 plus 9k and then just 9k, when I plug in 0, I would get 8 and then I would get 0. That doesn't make sense. It's not the interval from 8 to 0. It's the interval from, so that's why we switched this from 9k to 9k plus 9. And so, yes, now it's the interval from 8 to 9. Okay, anyway, that was a little tedious, but hopefully that made sense. Continuing on, H is decreasing at an increasing rate. So H is decreasing, my graph is going down at an increasing rate, and it's concave. Oh, I just dropped things. Let's try that again. And decreasing at an increasing rate. It's decreasing here, but it's concave down, so it would not be at an increasing rate. It's decreasing here, and it's concave up, so that's what we were looking for. And so I'm going to say 4 plus 9k to 6 plus 9k. It could be argued that I should be using hard brackets, but I really don't want to get into that argument, so whatever. Okay. H is decreasing at a decreasing rate, so it needs to be decreasing and concave down, and that's that little bit. It's going to go from 0 plus 9k to 2 plus 9k. Okay. Oh, and this next one, I was doing the practice that I wrote, and this next one was a little tricky, the way I wrote it on the practice. So let's see if I can make this make sense. Okay. So it says, let H be graphs on the domain negative 100 to 100. How many local maximum would there be? Well, so every period is actually starting with a local max. So we need to figure out where exactly, how many periods are we including here. And our period is 9. And so what I have here is that this, I could rewrite this as negative 1 plus 9 times negative 11. Am I correct? Let's see, that's negative 99 plus another one is a negative, my brain stopped, negative 100. Whew, okay. And then the other would be 1 plus 9 times a positive 11. So I have a total of 22 complete periods when I go from negative 100, because each one of these is telling me how many periods. So I'd have 11 periods going in the negative direction, and I would happen to have 11 periods going in the positive direction. So there's 22. And now we need to consider, okay, so what happens if I go one unit past the period? Okay, so if this is that last little bit. So if okay, say this was at, instead of this being at 0, let's switch this to negative 99. Okay, to go to negative 100, what I'm doing is I'm taking this little piece and coming down like that. And so now, okay, I've made it to negative 100, and there wasn't an additional max or min. Okay, the other would be, if I say this were at 100 right here, if this were 100, then when I go, or no, that was not 100, it should be 99. If this is positive 99, then what comes next? Well, what comes next, oh, no, this is actually 98, because I didn't graph the whole thing, do you remember? So this little piece right here, and then this, oh, hey, there's a straight line. And then it comes to 1 unit past, that would be here. So this, okay, well, it's too cluttered. This little bit, hang on, let me try this. Okay, this little bit, this got right here, got us to 99. And so then this little bit right here then gets us to 100. This is, anyway, sorry, it's on top of all this clutter. And so there is not an additional max or min that we need to consider beyond the 11 max here. I don't know why I'm talking about minimums. But there's 1 maximum per period. So there's a total of 22 complete periods, which tells us, that implies there are 22 maxima. Okay, I hope that made sense. Like, subscribe, comment, let me know if you have any questions, concerns, and as always, go practice.